Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 20th, 2026, just about 6 days ago. It proposes a hybrid attention architecture that explicitly decouples long-term stable preferences from short-term intense spikes, delivering over an 8% improvement in hit rate for users with ultra-long sequences. The paper is titled HyTRec, a hybrid temporal-aware attention architecture for long behavior sequential recommendation. And as we'll see later, the model's ability to maintain linear inference speed while outperforming strong baselines is really impressive. Figure 1 illustrates the evolution of attention mechanisms leading to this proposal. In panel A, we see standard softmax attention, where the central n-by-n matrix creates a computational bottleneck that grows quadratically with sequence length. Contrast that with panel B, linear attention, which restructures the math into a smaller d-by-d form to achieve efficiency, though often at the cost of precision. Finally, panel C presents the hybrid attention architecture. It strategically stacks multiple blocks of efficient linear attention, and then interleaves a softmax attention block to restore high-fidelity retrieval capabilities without sacrificing overall speed. So, Figure 2 details the full HyTRec framework, illustrating the dual-branch strategy. First, on the left, the model splits the user's behavior sequence into two inputs, a history segment for long-term patterns and a now segment for recent interactions. The top branch processes the massive history using a hybrid stack. It repeats efficient blocks called temporal-aware delta networks, or TADN, and periodically inserts a standard attention layer to maintain context. Simultaneously, the bottom branch focuses solely on the recent now items using high-precision multi-head self-attention. Finally, on the far right, these two streams merge to generate the output probability for the next item. Alright, moving to the results. Table 1 tests the model on the 2022 Huawei Advertising Challenge dataset, focusing specifically on cross-domain transfer. This is a tough scenario where data distributions shift between contexts. Comparing the proposed method against the HyTRec baseline, the performance gap is massive. While recall at 10 sees a solid bump, the AUC and GAUC scores drastically improve. For instance, HyTRec manages a GAUC of only 0.42, which suggests it fails to generalize, while the new model jumps to nearly 0.88. This indicates the hybrid design is highly robust to domain shifts. Next, Table 2 expands the evaluation to 3 standard Amazon benchmarks, beauty, electronics, and movies, and T versus comparing HyTRec against strong baselines like HyTRec and HSTU, we see distinct wins. In the beauty dataset columns, HyTRec achieves a hit rate at 500 of roughly 0.66, significantly outperforming the runner-up, HSTU, at 0.58. It also secures the top AUC score here. While the hybrid model QN Next edges it out slightly on electronics, HyTRec consistently ranks first or second, proving its efficiency doesn't come at the cost of accuracy. So, while Table 2 showed accuracy, Figure 3 demonstrates the massive efficiency advantage. This chart plots training throughput in thousands of tokens per second against sequence length. The blue line shows HyTRec maintaining high speed. It starts around 85,000 and only drops to about 47,000 at a sequence length of 12,000. Meanwhile, the purple line for the HSTU model plummets. It collapses to under 10,000 tokens per second at the end, making the proposed model nearly 5 times faster for long user histories. Okay. Having established efficiency in Figure 3, Table 3 now isolates the contribution of each component using the Amazon Beauty dataset. The first row displays a baseline without the temporal-aware delta network or short-term attention, where the hit rate at 500 sits at just 0.60. Adding only short-term attention improves this to roughly 0.63, while adding just the temporal-aware delta network bumps it to nearly 0.65. Finally, the bottom row shows that combining both features yields the highest hit rate of 0.66, proving that capturing both immediate intent and long-term drift is essential. Wrapping up, 2 takeaways stand out. HyTRec proves that hybrid architectures can break the trade-off between linear speed and softmax precision. By decoupling long-term history from short-term spikes, it enables real-time processing of lifelong user sequences, offering a scalable roadmap for industrial recommenders. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.